This is 2025 paper 2 question 5. So we're told some information. C is the midpoint of AB. So that means that this side is equal to this side. And AD is parallel to EB. So I'll just show that with some arrows. And then C lies on DE, which is kind of visible. Prove that ACD and BCE are congruent. So let's just see what we know is equal. So the first thing we know that's equal is that the length AC will be equal to the length CB, and that's because C is the midpoint of AB. We also know that the measure of the angle ACD is going to be equal to the measure of the angle ECB. So that's, I'll draw it in green, that's this angle and that's this angle, and they're equal because they are vertically opposite. And I suppose that is made very clear because C is on DE, and AB. So it's kind of like the intersection of those two lines. So they told us that very explicitly in the question, so it's a good idea to mention it. And then we also know, I'll draw in pink, that this angle is going to be equal to this angle. So we can write down, and I'll show the reasoning in a second. So DAC will be equal to the measure of angle CBE, and that is because they are alternating angles. And we know that because we are told that DA is parallel to BE. So that's two angles and the side in between the two angles. So then we can say by angle, side, angle, the two triangles ACD and BCE are congruent. So we made three statements, show that the angles, one side is the same, and it's important that the side is in between the two angles, and therefore they are congruent. So then in part B, we're given an enlargement, and we're told to find the scale factor of the enlargement. So of course, the way that you usually kind of do this is you take one side length of the enlargement, and then you divide it by a side length of the original. But here we're given distances from the center of enlargement, and it turns out that if you take the distance from the center of enlargement, which here is x, and then if we take the distance from x to q prime and divide it by the distance from x to q, that's also the center of enlargement, which is a fact that you can prove. So, yep, that's basically what we're going to do. So this distance here, we're told, is 8, and this distance here is 4. So basically, the distance from x to q prime, so this is kind of like the new enlarged distance, and we divide that by the distance from the center of enlargement to the original q point. So basically, the distance from x to q prime is going to be 12, as you can see from the diagram. And then the distance from x to q is just 8, and that gives you 1.5. So then we're told some more information, and we're told the area of PQRS, which is 20 centimeters cubed. We're also told this distance xp here is 3. And then we're told to find the area of the shaded region. So there's a few different ways to do this. I think this is pretty tricky, but the most straightforward way of doing this is we can basically find how much of this, so we know what PQRS is. If we can figure out what percentage of PQRS is shaded, then we can just multiply the area by that percentage. So basically one way we can do that is we could find out what is the ratio, what's P prime Q going to be divided by the total PQ, and that'll tell us what percentage of this shape is shaded, because the ratio of the side lengths, how big is P prime Q relative to PQ. So we just need to figure out what those are. So it's nice if we have the previous part of the question up to. So now the distance from x to q is going to be 8. And then the distance from x to p is 3. So the distance from p to q will just be equal to 8 minus 3, which is 5. So now that we know what PQ is, we can figure out what P prime Q prime is, because we know that the scale factor is 1.5. So that means that P prime Q prime will be 1.5 bigger than 5, which will give you 7.5. And then if we take away, so this is P prime Q prime. If we take away Q prime, then we just get P prime Q. So if that means that we can say that P prime Q will be equal to, so again, this entire part here, that's going to be 7.5. And then we know q prime is 4. That's from the down there, the previous part of the question. So we do 7.5 minus 4, we'll get 3.5. So then, obviously, we can figure out what p prime q is over pq, as I wrote down here. So that's going to be p prime q 3.5 over 5. And if you put that into your calculator, you'll get 7. Well, you get 0.7 basically. So that means that p prime q is 0.7 times as big as pq. So that's kind of like a proportion of the shape there. I keep saying the shape, I mean the parallelogram. So that means that the area is going to be 70% of the original, because p prime q is 70% of the original in terms of size. So we can just do 0.7 times 20, which is equal to 14 centimeters squared. Another way you could do it is you could find the area of PQRS. You could find this angle here, and then you kind of like have some slopes and stuff. But if you find the area in terms of that angle, then you know this angle here is the same, and then you can use that because we know what P prime Q is to find out what the area is.